Hello, welcome to this live demo of Continuous Intelligent Validation, cIV. We just released our version 2.0, and let me tell you, cIV can do magic. It can completely automate the generation of URS, test plans, it can generate trace matrices, and execute the test scripts with no or very little human intervention. Human intervention is needed only to review and approve documents. Other than that, everything can be handled by our agents. Let me step back. XLM has been building continuous validation platform for almost 10 years now, but the last 2 years we invested in building a brand new platform based on agentic AI. Our goal was very simple. We wanted to automate any browser app, any desktop app, or mobile app using agentic AI. We also want to make sure that whatever we do complies with 21 CFR Part 11, the predicate rules, X11, now Annex 22. So that was our goal. Simple, but we figured out that it may not be that easy either. So we have released 2.0. It's in production and it's being used at many pharmaceutical companies. And I can tell you, it works like a charm. And you will see that in this demo. So wear your seatbelts and get ready for the drive. Before I start the actual live demo, just wanted to spend a few minutes giving you the baseline of what cIV does and what you can expect in the demo. Here is the agenda. I will quickly go through what cIV is all about, why cIV now. I will also discuss the architecture. What is cIV? cIV is efficiency. Our goal is to make sure that cIV increases cost efficiencies by 90%, which means that you will spend only 10% what you are actually spending now validating software using your outdated manual methods. That is the bottom line. We are elevating testing standards by using AI and using our strong foundation in test automation and our regulatory experience. We are bringing state-of-the-art software testing to the pharma companies. And we are doing this by integrating AI. The latest and the greatest in agentic AI is integrated into our product. We're using the best of breed, state-of-the-art frameworks, and we have put a lot of effort into developing cIV, and which is built on our continuous OS platform. So here is a comparison. On the left side, you will see our legacy model. On the right side, you will see our cIV, the latest iteration of cIV. When we started doing test automation with our legacy platform, we would write test scripts using the BD frameworks, meaning our QA people would put the high-level test script definition using the BDD language, and that's called the feature file. Then our developers would develop the code, the test automation code, and most of it was based on Selenium. And our platform would execute the test cases and give you a PDF that met all the requirements of software validation. How do we do it today? It's very simple. You come to our portal and submit a ticket, and whether it's a URS needed, whether you need a test script, you need a trace matrix, or you need a test plan or a test script executed, you just submit a simple ticket, and I'll walk you through the process. And our agents will take over the ticket, perform everything that's needed to be done, and every step of it is audit trailed and logged, and it will give you the output, whether it's a URS, draft document, trace matrix, test plan, or an executed test script, which we call the TPE, test protocol executed. That's how it works today. Why cIV? cIV is a game changer. What we have done with cIV, I don't think anybody else in the world has done with I combining that with strong regulatory foundation. So it meets all your predicate rules as well as Part 11 and Annex 11, but also leverages SOTA, which is state of the art AI models, to make everything go seamless, super fast, and super inexpensive. I don't think there's any other platform or framework that can beat our technology. It's been built ground up, and we promise you our cost efficiency is a minimum of 10x. Time compared to manual, maybe 1% of what it takes you as compared to your manual way of doing things. How do we do it? And here is a very high level diagram, architecture diagram that lays out how our framework works. The back end is where all the magic happens. Our agents go to work and take care of what needs to be done, whether it is executing a test script or authoring an URS. From a front end point of view, you just come to our portal, pick the ticket that you would like to submit, fill out some basic details, and push the button, and the system takes over and you get the output. And I'm going to showcase all this in the live demo. You're looking at XLM cIV portal, and you're also looking at the URS ticket. So to generate a new URS, you simply put in the title, the platform that you would like to generate the URS for, and the prompt. The scope is a prompt. So in this case, we are trying to generate an URS for Jira's ITS, and we would like the scope to include 7 different workflows. So this prompt is very important. The more specific you are, you get a better output. You can keep it very simple, or you can give it very specific details on what needs to be included. And once the prompt is there, we have various samples, the best practices for prompting. Once the prompt is done, you can upload any multimodal file. What I mean by that is you can upload handwritten sketches, you can upload meeting minutes, audio files, meeting audio files, or maybe meeting video files. So anything that you have, maybe an SOP, maybe some old reference. So you give the agent some background information, and it doesn't have to be structured. It could be unstructured, but you just have to give the background information. That way it can design the URS and author the URS that's closer to your expectations. Once you hit the send button, the magic kicks off. So you will see that here, this ticket has already been executed, and the audit table will show here. So these were different evidences that were given here to describe the different workflows. There are about 7 workflows within this particular URS, and every single step is audit trailed. Looking at what exactly happens during this step-by-step process, and it takes about 15 minutes to digest all the information and gives you 2 outputs. One is the URS document, draft document, which the author can, or the initiator can review it, edit it, or come back and reprompt it based on whatever your needs are. Then it also gives you the thinking, what the model is doing in the backend, and every step, what the thinking process, every step is documented in this log file. So you get 2 outputs. One is the draft URS and the log file. If you look at it, this is the log file. It gives you what exactly happened during the thinking, and every single thing is documented in this log file. It's very detailed. If you want to look at it, anybody who wants to look at it is more than welcome to look at it. We, by default, attach it. But this is the output of the ticket, which is the user requirement specifications. This can be, you can use any template that you want. If you have your standard template, you can use that. It, based on the input that you gave, it authors every single section in this URS, from the scope and gives detail what was in the scope. And also it clearly lays out what's out of the scope. It can generate definition acronyms and typical stuff. It can generate that. But this is where all the requirements are done. So it's technically accurate, very well organized in terms of sections, and it's very readable. It can consider your corporate policies as to what what is your philosophy in generating URS? What is the template to use? What should be included from a regulatory point of view, irrespective of the system type? All that can be used to train the bot, and the agent will give you the output accordingly. So in this case, it generated about 23 pages in about 15 minutes. Not only gave you the text, but also gave you the workflows, because sometimes it's easier to define the user requirements using a workflow, and the bot decides which ones need a workflow, which one doesn't need a workflow, and accordingly has includes the workflows as well. So in effect, by just giving a simple prompt and a multimodal files, whether it's audio, video, PDF files, drawings, sketches, handwritten notes, anything that you have from the project background point of view, you just upload it, and out comes a very well structured URS document that's ready to be reviewed, updated, revised, and sent out for approval. I mean, it cannot really get easier than that. In most cases, the URS that gets generated is better than what an SME can do. And typically an SME will take days to do it. This can do it in minutes, and you get a very good document that gives you the baseline, and you can edit it and get it approved the same day. That's what our URS agent does. Now you are looking at the ticket for generating a test plan. So you would like to generate the test plan. That's the second step. You already saw how to generate an URS. Now, once the URS is done, the next step is to design a test plan, get it approved, then execute the test plan, also in parallel, generate a trace matrix. So these are the four basic blocks of any software validation SDLC. And that's what cIV automates using agentic AI. In this case, for the test plan generation, we have three options. One is auto generation of the test plan, meaning the bot automatically gives you a draft test plan based on the URS. The second option is you record a video. So let's say you have a test case, and you record a very simple video and showcasing what needs to be done. You can upload that video to the ticket that I'm just showing, and out comes the test plan. And for some advanced users, we also have a plugin which anyone can use and walk through the use case in a browser or a thick client, and the recorder will record every step, and that's enough to generate the test case. So we give you three options, just to summarize. One is the bot can automatically generate the test cases, option one. Option two, the end user records a video of what needs to be tested and gives it to the bot, and the bot generates the TPG or the test plan. And lastly, for advanced users, we have a recorder which can record the screen as you are navigating the various steps in the test case, and it records it automatically. At the end of that session, it generates a text file which can be edited again. It's all in English, and that can be input to generate the test case as well. So we give you three options to cover the various scenarios for our enterprise customers. In this demo, you'll see, and all of them work in a very similar fashion. This is one example where you upload a video and out comes the test plan. So in this case, you give it a very simple title and you choose a platform name. So our bot knows what platform are we talking about. And then, you upload a video file. And let me show you. So this is a sample video file. You can, so the test case has been recorded and this needs to be uploaded. And that's what happened here. Let me go back to the screen. So I've already opened up an executed ticket. So if you look at it, the video was uploaded and out came the test plan and also a log file detailing everything the bot did, what the thinking was. Everything is given as an output as well. Also, every step in this process is audit trailed in the ticket itself. So let me show you the log file. So this is the log file. It's a pretty long file because every step it is executing as part of the test plan generation, it's there. So what it's doing is it takes frame by frame. It also listens to the audio. And based on that, it creates a test plan. It's almost magic. If you asked me 2 years ago if we could even do this, I would have said, yeah, maybe 10 years later. But here we are. This is version 2.0, and it is delivering a detailed test plan based on a simple video. How does the test plan look? Here we go. So this is the output that you get, which is the most important one, which can be edited. It's a Word document, right? So you can edit it, you can revise it, or give it a new video or an updated video and regenerate it. It takes a few minutes to get the output. So this is a test plan. And based on the video, it clearly records everything that it saw in the video and outcomes, in this case, 77 steps. And also you get a properly formatted document that can be reviewed and also approved. That is our second agent, which generates the test plan. And the next section, you will see how this test plan is used to execute the actual test case. What you're seeing is the ticket to generate a TPE, which is test plan generated, meaning you give our agent an approved test plan or test script, it will execute it and give you the evidence in a locked PDF file with all the screenshots and whatever you typically expect in an executed protocol. That is what you'll see in this particular demo. So in order to get started, you need to go to test automation cIV ticket. You enter your title for the execution, the platform, and give it any reference numbers that you would like to include, that will be added here. Then the document number that you want, you enter it here. Also enter a comment and upload an approved pre-approved test plan or a test script or a test protocol and push the send button. So what happens, once you push the send button, in the background, it kicks off a pipeline. The pipeline will create a virtual machine and load the test automation code that's needed to run this experiment. And that comes from a production repository, code repository. It builds all that, deploys into the VM, and executes the test case, generates the raw files. That gets passed on to the report generator, which generates a PDF file and formats it and includes all the attachments, the bookmarks, and it's nicely packaged. So the whole process is happening in the backend. As far as the user goes, you just enter a simple ticket and give it the pre-approved protocol, and few minutes later, you get an executed protocol. So that's the power of our cIV platform. So what really happens from a user's point of view, every step is recorded. What the bot does, what the user does is recorded in the ticket itself. That's again an audit trail that's recorded. The input is the test case, and you get a TPE, which is the formal document or executed protocol that needs to be post approved. You also get a video of the session, and you get a detailed log as to what exactly the bot was doing from the time you press the submit button to the point when the PDF got generated. So that's the 3 deliverables you will get for this particular ticket. So this is the video. You will see that, in case somebody ever doubts something, you will see that it's there. So the whole session is recorded. So it's not magic. The agent actually logged in and did all the work like you expect. Then it also logged every action here. You will see that, you see in plain English. Now I clicked on this, I did this. So you will see what exactly is happening. And that's also logged just for your evidence from a compliance point of view. That also is given. But this is the document that you will need to get your post approval done. So it's PDF, it's locked. It has all the bookmarks. You look at it, it's nicely bookmarked. If it has any attachments, in this case, there are no attachments. If the attachments, that's listed there. It captures the environment detail, all the text execution detail, it captures it. And it gives you a nice summary of that the test cases that were executed and the result. If it's a failure, it will still document everything, including the error that happened or the step failed and why the step failed. That is automatically logged in, and the ticket gets opened in our QMS ticketing system in case that fails. So this is how the test case looks. So every test case gets a test case name, an introduction, which includes the objective and acceptance criteria. Also, every step you will see a step description, expected result. This comes from the pre-approved protocol, and in the actual result it's generated in real time with timestamps and screenshots. So everything here is captured. I mean, there is nothing that it's hard to make up any of these things because you get the screenshots, you get the timestamps, and you get the video to go with it. So it's rock solid from an evidence point of view, from a partner compliance point of view. So you will see that every step is done. And even in the step description, it clearly records, a click on unassigned, it's very clear, very prescriptive, very clear. And also everything is asserted. Not only capture the screenshot, it makes sure that it can read the screen and it validates it as well. So nothing is taken for granted. When a typical tester does, sometimes you might just sign off and not really do a thorough job. But in this case, the bot is doing everything that it's supposed to do, and every validation, every assertion is accomplished. So that's how the TPE looks. So just to summarize, if you want to do a test case execution, whether it is a browser, whether it is a SCADA system, which is typically a Windows app, or if it's a mobile app, you can submit the pre-approved protocol, fill in some basic information about this particular session, the session information, push the button, and everything happens in the background, and out comes the video, the log file, as well as a TPE, which is for post-approval. And this is a secure PDF. It includes all the bookmarks, any attachments, everything's included, and every step is a screenshot. It's captured also. And it clearly states what is the step description, what was expected, and what did I give? Now, what was the actual result? It's all documented. And this execution, if you go back to the second page, it took 28 minutes and 53 seconds. It got this done. So again, depends on the complexity of the use case and the number of assertions done. And it not only executing it, it records the video, gives you everything to you. It's logging, doing a lot of logging. All these things slow down, but this whole thing got done in half an hour. Thank you. you are looking at the ticket to automatically generate a trace matrix. As all of you know, if anybody has generated trace matrix, you will know it is a mundane task, and sometimes you're chasing a moving target, or in most cases, you're chasing a moving target. More often than not, auditors will always find mistakes in the trace matrix. So you can imagine if you can have a trace matrix generated in minutes and it's accurate, it's very extensive, nothing like it, right? And that's what cIV's TM agent does. So if you want to generate a trace matrix, you come to the ticket, trace matrix ticket, you enter a title, platform. We support two-way tracing. One is you can go from URS all the way to test cases, or you can do reverse tracing from test cases to URS. So we have two-way tracing ability. You include some reference numbers in case you want to reference anything, and a few other fields that you need, like the titles and things of that nature. And also we have one more option here, which is if you want to make sure that the documents you're uploading, the URS and the relevant pre-approved test protocols, if it needs to be a e-signed documents, meaning it is formally approved documents, or you're just doing it during development and doesn't have to be a pre-approved documents. So you have the feature here as well. Then you upload the relevant files. Typically, it's the URS as well as all the pre-approved test cases. So you put that together, and once you submit it, you should have the TM in a few minutes. So here it's a previously executed ticket here. Just like I showed you, all the information has been entered. The URS and the relevant test cases have been uploaded. Out comes a TM and a log, meaning the agent log, what exactly the agent did in order to generate this TM. And every step of this process is audit trail in the ticket itself. So let's look at the log. This is just for a compliance point of view. If somebody asks, this was done by an AI agent, what did the agent do? So this is exactly why we have it. It records every step the agent does. And also, it's really not needed because the TM has to be reviewed by the subject matter expert as well as the QA expert and edited, approved, updated, and approved. But still, we are taking a very conservative approach and giving you the log file. Of course, we give you the TM itself. If you look at it, it gives you a typical Word document that has been generated on the fly, and it has all the sections you typically expect. But more importantly, it has the mapping, or the URS to test mapping. This is pretty accurate. We can guarantee you 90% plus accuracy on the mapping itself. So it goes through every single requirement in the URS document. It captures the actual requirement, goes through various test scripts that you uploaded, and adds all the relevant test cases. This is how a typical trace matrix looks, and it exactly does the job. Only thing is, it does this in a few minutes, and that's the only difference. In this case, it's like 23 pages, and it's got quite a few requirements. We go through it. It has about 65 requirements, and the mapping was done in a few minutes. So in a typical projects, all these documents are a moving target. The URS may be changing, the test scripts may be changing, the system development is happening. So you need the ability to generate this accurately in an expeditious way with no manual effort at all. So that's what cIV's TM agent does. Thank you.